Okay, so what we can do here is we can draw a line, any old line, and it's not touching the circle. Now, as I make this line closer and closer and closer, at one point, it's going to just touch the circle in one spot right there. So right at this spot where it's touching the circle, if we join a line from center, the only possible way for it to join is to join perpendicular. So a tangent line is perpendicular, that's the upside down T. Okay, so this means perpendicular to a line from center. And what two lines can we have coming from center? No. If it goes through center, it's a special chord called a radius or a diameter. Okay. Now the radius would not be a chord, but the diameter is a chord. Okay, so it goes from one side to the other. And that's all we're learning today, that we have another way of having a right angle. Okay. So perpendicular, remember the symbol for perpendicular, that's the capital T upside down. Right? Where it joins at point D, we call that the point of tangency. The line is called a tangent line. And look for the radius or the diameter. Okay. And so here it is printed out for you. A tangent line is a line that touches a circle at exactly one point. Connect the point of tangency to the center of the circle. This radius and the tangent line form a right angle, and that means that they are perpendicular. Okay. Any questions? So let's look at the three examples we have. So example number one, we have number one, angle 1 being 90 degrees, and the reason is that a line from center is perpendicular to the tangent line. Okay. So we can mark that as 90 degrees. Now for angle 2, we can't find that. Not directly. We have to find it indirectly. And that's what you're going to find today's homework, is there are going to be more indirect questions. What we actually have to do is work in this triangle and find this blue angle first. So all triangles add up to 180. So it's our triangle rule. So 180 degrees minus 90 minus 50 equals angle 2, which is how many degrees? 40 degrees. Make sure you have a degree symbol. Some people have forgot them a couple times. Yes? Oh, I'm not finding angle 2. You're right. Sorry, erase that. So that's the wrong angle. Now to find angle 2, we use the angles on a line rule, AOL. Angles on a line equal 180. So for angle 2, it's 180 degrees minus the blue angle. So it's going to be 140 degrees. Thank you, Sarah and others. Okay, so angle 2 is 140. So you couldn't answer angle 2 until you found the blue angle. Good. Now what kind of triangle is angle 2 inside of? An isosceles. So you need to mark those two radius or radii as being equal. So now that we have an isosceles triangle, the isosceles triangle, once we have the top, we can take 180 minus 140, which is 40 degrees. That's the bottom two angles. Okay, the two equal bottom angles. So how would you find one of those two equal bottom angles? Divide by 2. And so that's angle 3. Okay. How then would we find angle 4? Again, we can't find it directly. But what else do you have to know about this angle here? Yeah. You have to know that this green angle is also 20 degrees because it's a base angle. Diction question? Okay. So then, what else do we know about angle 4 in this green angle? Diction? Good. So angle 1's 90 degrees. Angle green and angle 4 are also on the tangent line, so they also add to 90. And together, Tiction's right, the tangent line will be 180. So angle 4 equals 90 degrees minus the green angle. So 90 degrees minus 20 degrees, which is 70 degrees. So again, I tell you to find an angle, but you got to do more work first. So you're going to see that today. You have to use your rules to find more than just what I'm asking for. Okay. Any questions? Okay, so we're stepping it up a little bit. Okay, example number 2. AB is tangent to the circle at D. So what do we know about the point of tangency? D, what do we know about that? 90 degrees. Good. We want to find angle 1, but we don't have enough information. You know what would be nice though? What would make it easy to find angle 1? Diction? Yeah, if we knew this angle right here, that's a triangle. We know 180, right? Triangles add to 180, so we know that would be easy. Is there a way to find that red angle? Olivia? Nope, that's not going to work. Can't do one of those. Okay? But I give you 140 and I give you 80 for a reason. What kind of angle is 80 degrees? Is it inside a circle? And angles are inside circles are inscribed. Oh, just a sec. Here's the feet. And it's inscribed. Okay. So what else do we know? Tony?
You know that if it's inscribed, that
Yep.
140, it should add up to double 80.
Right. But the angle that's double 80 is this big thing.
Yeah,
So, good. 160. And so what's the red one then?
20.
Right. It's 160 minus 140 equals 20 degrees. Sarah, go ahead. Okay. So now that we know that red angle, you can find angle 1. So we can use our triangles add to 180 rule. So angle 1 equals the total sum of a triangle, 180, minus 90, which we have to figure out, minus 20, which we have to really figure out. Altogether, angle 1 equals 70 degrees. And angles always have a degree symbol. Okay. Good question, isn't it? Right? Like that's pushing it. That'll be one of the harder questions. I ask you one question, but you have to do a whole bunch of work to get the answer. Okay? So that's the upper level type of questions. Oh, it's fun. No, it totally is. Okay, please cross this off. You want to make sure you follow your unit outline, okay? It might all be the same, I'm not sure. I don't double check that. Okay, good. Okay, please write this information on your triangle real quick. Go. Okay, so you should have AD as 25. It's not degrees, it's just units, like centimeters or meters. AB is 7. Good. AB is tangent to the circle. Now, I didn't underline it. What should we mark as well? Perpendicular. So we should mark it as 90 degrees right here by B. Okay. So what we can do now is we can do Pythagoras using 25 and 7 to find BD. Okay, so find BD, show your work. I noticed on the quiz a lot of people I took a mark off because you didn't do your work for Pythagoras. Nelson. So we should get 576, and then when we square root that, we get 24. Okay, this is the bare minimum amount of work for Pythagoras. The bare minimum. And you guys should show more to be more careful. Okay, but when you become an expert, that's the bare minimum. Nothing less. So you should show it exactly as I am. Don't make new stuff up. Okay, good. So this whole thing here, from one side to the other, is 24. What's the length of BE? Right here. Why 12? Right. So what we're saying here is Tim's saying this line is half the diameter, which is BD, and that's 12. And since they're marked as 3 equal sides because they're an equilateral, BE must also be 12. Okay, because those two sides are equal. Good. Now, what's the angle for BED? And why? Not 60. 60 is BEC. We want BED, the big thing, not the little part. Okay, that's fine. Okay. It's a rule. First of all, we'll look at its feet. Its feet are at B and D. What other angles at B and D that we know is 180 degrees? That thing called the diameter. These straight lines equal 180. Some of you missed that on the quiz. So if the straight line's 180, and that's the central, the angle BED, which is the inscribed, should equal 180 divided by 2, 90 degrees. That is our rule. If you're inscribed to the diameter, it's 90 degrees. Okay. Now we can do Pythagoras to find DE. So what we're looking at is this big triangle right here in red. Use 24 and 12 to find DE. Go. Well, do you have the hypotenuse, or are you trying to find it?
I'm trying to find it.
No. 24 is the hypotenuse. It's across from 90.
Oh, wait. Yeah, sorry.
Okay. Round to the nearest tenth, please. 20.8, is that correct? Okay, so you have the hypotenuse, which means you have to subtract. Don't make anything larger than the hypotenuse ever. It's the largest side. Okay, any questions?